Hello and welcome to this episode. In this video, I am going to explain to you a scalar dot product or the scalar dot product of vectors and how they are applied in machine learning by taking the operation of a single neuron into consideration. To start with, a scalar dot product is different from the element-wise product that you saw in the previous video when I was talking about vectorized operations. Okay? In the element-wise multiplication, what we did was, if I had two vectors, say A is equal to x1, x2, and then B is equal to y1, y2, then A times B was simply the multiplication of x1, y1, and then x2 times y2. This is what the element-wise multiplication of two vectors gave us. What you need to keep in mind is that the number of entries in each of the vectors should be the same. So the vectors should be equally sized in terms of the count or the number of elements in them, so that you can do element-wise multiplication, and the same applies to scalar dot product. But the mathematics is different from what you are seeing here. So what you see on the board is a single neuron. And this is a very simplified view of how a single neuron operates. So a single neuron over here, I'm going to represent it as an N, so you know this is the neuron we are talking about. The way it operates is that it takes in input and then it assigns a weight to each of the input. Now, the weight represents how sensitive the output here. So let's say this is going to come up with an output Y. The weight that the neuron assigns to each of the input, and this input is going to be the features of the training example that is coming in. So if I use a training instance from the previous data you saw, then we had one training instance where x is equal to 1.0. So the guy went for all the classes, studied, I think, 8 hours, and then slept for 8 hours. Okay? So if this is the training instance, the neuron is going to assign weight to each of the features. So x1 represents the first feature in the training instance, x2 is the second feature, x3 is the third feature. Let's assume that for now our weight vector is also such that we have 0.5 for W1 and W2, let's say, is 0.7, and W3 is, let's say, 0.2. Okay, what is going to happen internally over here in the neuron is that the neuron is going to do what is called a weighted sum. A weighted sum simply means that you multiply each weight by the feature and then you sum the result. So what is going to come out here is going to be the multiplication of each weight by the given feature, each weight by the given feature, weight, given feature, and then you sum it up. So as you can see from here, you say x dot w is going to be equal to, so 1.0 times 0.5 plus 8.0 times 0.7 plus 8.0 times 0.2. Okay, so as you can see, this dot product is going to return a single number, which is a scalar. It is different from the element-wise multiplication that I showed you at the start of this video. And the way this can be written mathematically, the reason I didn't write the mathematical formula before explaining is because I don't want you to worry about the math. Rather, I want you to understand how it is done. But mathematically, we can say S dot W is going to be the summation from I, starting from 1 to n, xi times wi. What it means is that this formula here is going to work for two vectors that have the same number of entries. In this case, n is 3. So what it's saying is, for starting from 1 to 3, read the x at that element, multiply it by the weight at that element, and sum the result. That is what this summation symbol does here. So what I need you to understand is that the scalar dot product of two vectors of the same number of entries is always going to return a single number. That is why the name is scalar dot product. And the way we use it in machine learning is that once the input comes in, the neural network, or in this case the neuron, is going to do a weighted sum with the weight that it has learned. So the whole training of a neural network has to do with finding the right weight, which you can multiply with the input to come up with the correct output. And that is something that we'll be doing more and more in later videos. But for now, the focus is how this is done, and it is done through weighted sum or scalar dot product. So thank you very much for watching, and I will see you in the next video.